When you take the rod ends and shafts out, threaded shafts out from the package, you need to check them. First of all, just check to see that they're not bent. As you can hear, these ones aren't that round, but they are not bent. So check for any bends and ask for replacements for any that are bent. You have to check your threads, and this particular one has got a lump on the end and you can't screw it in. So you need to get yourself a file the threads on a chamfer like so, to take any parts that's been pressed on at an angle and all that. Then get a finer file and then just file the start of the thread so as it is then smooth to screw in. Also, the threads on the inside, some are difficult, some are different depths, so you need to tap them all out to the same depth with an M4 tap. It doesn't have to be a incremental tap, just a normal tap will do. Little die button down each thread. After you fold them, you need to test the quality of the bearings to see how much slop there is, and reject the ones that are too loose and ask for replacements, and try to match each one so that the stiff ones are together and the looser ones are up the other end. So a simple way to test it is you've got yourself the 4mm tool steel or the 4mm bright mold steel. The tool steel has closer tolerance, and you just simply put your bearing on and hold it there. Put your bearing on, hold it there. Put your bearing on and just put your finger underneath and that holds it there. So they're acceptable. Put your finger underneath. That one drops down by its own weight. That one is too loose. The way they're made in these particular ones, there's an aluminium sleeve on one side, aluminium on the other. They actually swage it over on a press and squash it together. So this one is too loose. So there's too much slack between the ball and the housing. So that one's rejected. So work out the ones that are no good and just move the other ones with your fingers, and you'll soon find out the ones that are tighter. That one's tighter than that one. So you say loose, you say loose, medium and tight. So you go through the whole set before as soon as you unpack it. You've got your tool steel, do the test. Reject the ones that are no good. Group the ones that are. Check your rods. Reject any bent ones. Then with the others, file the ends off, run the thread up. Then that's complete there. Run your tap down, your M4 tap down the same depth for all of these, and you're ready for the next section. Just by screwing the threaded rods in, these are aligned up here, and you'll notice down here that they're all at different lengths, varying by 3mm. So that's why you need to make sure the thread is correct on the threaded rod and tap those down to the same depth so as you can get the movement and the amount of travel, and also to make them in alignment. This distance from that hole to these holes there needs to be exactly the same end to end. But also, you also need to know what it is. So you need to make it, say, 230 mil. At the moment this one here is 228. Some are 225, some might be close to 230. So the way you do that is you use 2 bits of tool steel, place one in either end. This one will be easier, and you adjust each threaded screw to get the next one to line up. Now, these are not like a normal turnbuckle. A normal turnbuckle has a left hand and a right hand thread, which means that when this face is vertical and this face is vertical, you can just turn that and it will either expand it or decrease it, but these faces will still stay vertical. These are both right hand threads, which means when you screw this thread in, this one is unscrewing, so the overall distance doesn't change. It is an M4 thread, so that's 0.7, so one rotation of the shaft will alter this 0.7 of a millimetre. But unfortunately, these faces really of the housing should be parallel, so as when they move, one's not far to the right and one's not far to the left, so as you don't get as much trouble as if they're both parallel. So if you're going to, let's just say, change this length by 0.7 of a millimetre, which is one rotation of the thread, what you have to do is rotate one end that way half a turn, rotate the other end half a turn in the opposite direction, so they are then still parallel. So it's this end and that end, this end and that end, so it's a bit more difficult to muck around. That's why I will plan to put a little nut each end. You can use Loctite, that's fine, but Loctite, you have to put the Loctite on, screw it in as Loctite is drying, measure it, adjust it, measure it, adjust it. So depending on how far they're out, that type of thing can cause problems, can dry. That's why I'll use the nuts. Some people make up a jig that's got 2 holes in it already and they fit it in that way. That's also another way you can do it. And the third is to get yourself a 300mm vernier caliper. There's only a 200, I'll be using the 300, I'll show you that when it's up to that stage. And you just measure the inside of each hole and then you can get it spot on. So make sure the distances are the same and also that you've measured the distance, because you need that in setting up the printer. So once you've done that, fix it, check to see if the thread is running out, shaft is running out. File the ends of the thread smooth for chamfer, run down the M4 button die, clean them all up, tap each end of the ball end, same depth. You've checked the balls, you've rejected the loose ones, got replacements and done the thing. Screw them in, nip them up, measure, then they're set. That is finished. Some people say, oh, use carbon fibre. These come with the kit. Try what you've got with the kit. Won't cost you any more. If you're not happy, replace them later.